Alright, welcome to your weekly video. We may keep it pretty simple today, one little bit longer than last week's video, wrapping up clouds and satellite. The material that will be on this video is part of next week's exam. Anything following that with general circulation is not part of the exam. So again, this is fair game for next week's exam, and this will be detailed in the email that you receive on Friday morning as well. And so we ended class on Wednesday looking at different clouds. We talked about cirro, high-level clouds, stratus, layered clouds, all the way to cumulonimbus type clouds, your thunderstorm clouds that can extend through the greater depth of the troposphere. And so the majority of this video is going to break down these and talk about some of the finer features of different types of clouds. And so here's one of your hard-hitting graphic pages. This is why you pay the big bucks at Valpo, is to see stuff like this. Cirriform, wispy, fibrous. We're going to talk again about cirrus clouds being comprised of ice crystals. Not much of a threat in terms of adverse weather. Stratiform, again, can exist through multiple layers, and often if they're near the surface, these layered type stratus clouds can potentially produce precipitation as well. And then cumuliform, the ones that are, when you stare up at the sky, maybe you see some interesting shapes, little puffy cotton balls, but can develop into something much more menacing given the scenario. And so we're going to kind of work our way from the top down. And here you see an image of cirrus, a fair weather type cloud. When you have skies that have just cirrus, you are not going to have anything in terms of adverse weather, maybe windy or something, but not in terms of precipitation or anything on that order. They're comprised of ice crystals. These are high up in the sky where it's very cold. And so because they're made of ice crystals, they actually really don't pose a whole lot of a threat to just about anything. Even say aviation can fly through cirrus clouds and not have any big issues whatsoever. Sometimes they'll have the terms mare's tails, look like wispy little horses' tails. Again, not something to be alarmed about. Once in a while, as we start to see cirrus filling in a little bit, it may be a precursor of a mid-latitude cyclone or a series of storms that could move in a couple of days. Cirrocumulus, now we're still way up in the sky, but we're now finding little baby cotton balls, little puffs of clouds that are higher up in the sky, still generally speaking at altitude where these are going to be comprised of ice. You may see them form some lines. Sometimes they refer to them as little streaks or streets up in the sky. And so you see the term in the blue box, mackerel sky. So fish scales is what some people long ago thought these clouds look like. And so the way that cirrocumulus may jump out to you someday in your lives is if you're out in the evening in the setting sun and you get that red hint that just makes these clouds look beautiful up in the sky. Kind of a pretty thing. Again, as you can see though, often will fill in a little bit more as well compared to the cirrus clouds on the previous slide. Cirrostratus is, again, we're up and high up, very wispy but thin, yet now we're filling in. These are sheet-like clouds, and so this is going to be a better precursor that the weather may, in a day and a half, 2 days, maybe even 3 days, the idea that you're getting higher clouds well ahead of a storm system, and they're going to get lower and lower to the ground as you get closer to the system, and more moisture is available in the lower portions of the troposphere. And so these thin, high sheet-like clouds, as I put here, again, aren't going to be precipitation producers because they're simply too high in the sky. If you see this imagery, you can kind of see that halo around it. We'll talk about halos right at the end of the semester when we talk about optics. Basically sun and what the sun does when it hits ice crystals. It can create these pretty 23 or 46 degree halos. And again, the idea that it looks a little kind of milky sun. You know it's there, but you can't really see definition of the sun. So cirrostratus, again, not an imminent threat, but again, a sign of what may be to come. Stepping down a layer, again, remembering alto, our mid-level clouds. Here we're looking at cumulus, puffy clouds in the mid-levels of the troposphere. We're getting lower in the sky, and therefore seasonally dependent. These are going to be clouds that are actually comprised of water droplets. This does have bearing on things such as, I alluded to earlier, the aviation industry and whether or not clouds are going to produce icing on aircraft and things like that. The depth of altocumulus clouds can maybe get a little bit of precip, but we're talking high enough in the sky where what happens is that as the precipitation falls from some of these clouds, it likely would evaporate before reaching the ground. You can see that in this image it kind of looks like a sheet, but that there are individual elements. You can see breaks between the different cloud features here in the mid-levels of the atmosphere. And again, this may be one of those scenarios in which the day before or even hours before you might have had some cirrostratus, and now we're starting to work our way lower and lower as we're getting closer and closer to a parent storm. But altocumulus generally are not going to be anything to be concerned about either. Altostratus, more that idea of an incoming storm, lowering clouds with the approach, and this is going to make a lot more sense as we get into talking about frontal boundaries and the idea of mid-latitude cyclones and the stages of a mid-latitude cyclone. Here, because we're getting closer to the ground, because these are more water droplets as opposed to ice crystals higher up, we're going to start to have these have a more grayish appearance. Sometimes white, but oftentimes taking on a darker look to them. In this image, you can see the sun kind of peeking through. They'll oftentimes, again, call this kind of a milky sky. The idea that there is definitely a lot of water droplets that are helping to obscure what we can see in terms of the sun or the moon. And often now we're talking a day-ish out that you may be getting some worsening weather in the next day as we get lower and lower to the ground with these sheet-like clouds. Because again, mid-level stratus, altostratus clouds, mid-level sheets. Getting down closer to the surface, definitely not the highest quality picture here from a previous textbook, but here we're talking about sheet-like clouds low to the ground, stratus. It's probably not too hard to motivate stratus because we've had a lot of stratus so far since we started this semester. A lot of winter does bring some stratus type clouds because we have basically a lot of really cold air, and the way that the atmosphere works in winter is pretty easy to form some stratus type clouds. And so these are going to be grayish, can take on a dark or a light gray, sometimes even a whitish depending on where the sun is, how thick the clouds are. There's a lot that goes into clouds and cloud physics, and that's not something we need to worry about here. But when we talk about stratus, specifically stratus, we're not talking about low sheet level clouds that are raining. We're going to reserve that for another type of cloud that's upcoming. But you can get a little bit of light mist. Kind of feels like there's water in the air, but it's not actually raining. Drizzle. Drizzle's the idea that we're got a little bit of stuff kind of falling out of the clouds, but it's not actually accumulating at the surface. Not something that is necessarily going to be a pleasant day, but all kinds of different situations can produce stratus type clouds. Nimbostratus, again, this image to me always seems to look like a tornado just went through. I'm not sure why. Here we're talking about stratus that basically is producing precipitation. Here you get the definition of a continuously falling precip. It may be drizzling heavier, it may be raining steadily. There's no one defined rate of rainfall that has to be associated with nimbostratus, and I should be fair, rain and or snowfall. We've had obviously copious amounts of snowfall in the past couple weeks associated with, at times, stratus clouds. Here you can see some individual elements that may be below the nimbostratus. There's a slang term for these called scud or stratocumulus under downdraft. Again, what you're seeing here is rising and sinking motion, and that can produce some individual elements that seem to stand out from the overall cloud sheet. The image, though, again, trying to show some puddles on the ground to motivate the fact that this type of stratus is, in fact, raining. Stratocumulus, low and lumpy. What a beautiful descriptor for these types of clouds. Low to the ground, sheet-like, but because they're cumulus clouds, they're going to have individual elements to them. You see this image here, right on a beach with a large body of water. Stratocumulus can be found in all kinds of areas, but they're actually quite common along a number of our shores. Say the East Coast, when you have a cold air mass move out over the ocean is a little bit warmer, and that produces some rising motion to generate stratocumulus clouds. Because of how close they are to the ground, they can precipitate depending on what else is going on in the atmosphere, things such as lift and other forcing mechanisms, or they may just look like this, a generally pretty sight, and be relatively benign in terms of producing any notable weather. Again, the big thing here is the fact that they do have individual elements as opposed to simply a sheet. Here we have, boy, moons ago, you're probably all too young to remember the Windows background that used to look very, very similar to this picture. Kind of a quiescent scene here with some puffy little cotton balls in the sky. Cumulus clouds. Cumulus clouds are probably, for a number of you, if I said, do you pick your favorite cloud, and you groaned and you moaned and you had to pick a favorite cloud, a lot of you would pick cumulus clouds. They're generally speaking a fair weather type cloud. They can develop into something not fair weather, which is coming up on a subsequent slide. Flattish base, we'll talk about why there's a flat base in future slide sessions, specifically related to stability of the atmosphere. Rising motion will condense moisture at a certain level called the LCL, and that's where we're going to find the bases. And then they can have some variable tops. You may see little clusters of cumulus. You may see one all by itself in the middle of nowhere. The idea that nothing at this point is concerning, but they do have more of a vertical development to them. This is why, again, cumulus are going to be little cotton balls in some cloud of vertical development. Cumulus can develop into cumulonimbus clouds. Cumulonimbus clouds are probably, for a handful of you, your other favorite cloud. If I had to pick a favorite cloud, probably have to go with cumulonimbus for full disclosure. Significant vertical depth. We're going to associate thunderstorms with CBs or cumulonimbus clouds. You can see in this image a dark area underneath the cloud. Let me get my cursor over here. This would be where you're getting heavy rainfall. Other areas, we have rain-free bases to the clouds. Here you'd have some growing cumulus clouds. Here you'd have a mature cumulus. And here you can actually see rainfall falling out of the sky but not reaching the ground. So as we get into thunderstorms, we'll talk about various stages of a thunderstorm, and you can often see bits and pieces of that when you look at a cumulonimbus type cloud. Out here we refer to this as the anvil. Interesting features associated with this type of a cloud. But if you're talking about the types of clouds that are going to have your heaviest rainfall, thunderstorms, hail, and yes, even tornadoes, cumulonimbus is definitely the type of cloud. So how do we observe clouds other than going and laying out in the field south of the chapel and looking up in the sky? We have our satellites, which we've briefly talked about, but we'll spend a few more moments here in this group talking about satellites. We remember geostationary and polar satellites, geostationary being the ones that are high above Earth's equator and rotate at a speed that allows them to continually look down at the same spot on Earth. That's why they call them geostationary or geosynchronous orbits. Polar satellites are going to rotate, not surprisingly, around the poles, much lower to Earth's surface, or a much lower altitude, shall I say, and they're going to rotate around the poles while the Earth spins beneath it. So each time they come around, they're looking at a different picture underneath them as they come over the equatorial regions. Both of them have their purposes. The geostationary are very important for being able to see the motion of mid-latitude cyclones and thunderstorms and that type of feature, whereas the polar orbiters are going to do a really good job of looking at what's going on at the poles, which has proven to be extremely important over the past few weeks with our, well, pretty crazy polar vortex situation going on with the deep low that impacted the United States. We'll talk a little bit about visible, infrared, and water vapor imagery. I encourage you to take a little time to read about this. Is it the most important thing you could possibly do part of the exam? Absolutely not, but it is something that you're likely to see satellite imagery periodically moving after this class. And so knowing a little bit about what you're looking at is definitely one of those things that will help you a little bit moving forward in life. Visible is looking at visible satellite imagery, is looking at reflected visible light. So we've now talked about the concept of an albedo. It's effectively measuring albedo. Bright, white, puffy cumulonimbus clouds that are high in the sky are going to reflect a whole lot of visible light as opposed to clear skies, where we simply have the satellite going all the way down to the ground, and the ground absorbs that visible light, and therefore it doesn't reach the satellite. And so in this image right here, I won't click on the current data. I'll encourage you to do that in the slides. Here you can see areas with very dark imagery across Tennessee and Alabama, basically areas that are cloud-free. You can look at areas here over the plains into the Great Lakes, pretty clouded over. You can see some individual bright elements signifying some thunderstorms out here over the Gulf of Mexico and a number of other ones down here by the Caribbean. And so a lot of things that we can pick up using visible satellite imagery. Highly detailed, it's great for observing thunderstorms, but it does have, and you may recall this, one significant limitation, and that is the fact that it only works when the sun's out. And so it is, generally speaking, useless when the sun is down because we're relying on that visible light to be able to give us information at the satellite level. Here we zoom in on a few examples of cumulonimbus clouds. Here we have northern Colorado. You can see some texture to these clouds. Sometimes you get some really pretty imagery of cumulonimbus clouds when sunset is approaching. The idea that you're going to kind of see the shadows here as we have this squall line of thunderstorms moving from Wisconsin. In fact, you can see the texture all the way up here in the UP of Michigan, working its way down through Wisconsin, and then individual cumulonimbus elements back here into the state of Iowa. And then here, I think we got New York, a number of features up here in the state of New York, looking pretty menacing in some ways here on the satellite. Infrared is sensing infrared energy. Remember back to our energy section. Hopefully this doesn't feel long ago because it's coming up on the exam. The idea that everything emits energy that has a temperature above absolute zero. You, your book, your computer that you're watching these slides are all emitting infrared energy. And so the infrared satellite imagery is sensing how much infrared energy is reaching the satellite. The warm surface of the Earth is sending out a lot of energy. Cold cloud top, much less. And this all goes back to things such as the Stefan-Boltzmann law and Wien's law to understand in what spectrum of the, or what portion of the electromagnetic spectrum, but also at what wavelength is the maximum emission occurring. The big benefit to infrared satellite imagery is because things are emitting at all times, we can utilize infrared imagery at both day and night. The example here in this image is what's known as an enhanced image. We take the information and we can use computer algorithms to let us know a little bit more by colorizing, say, the colder cloud tops. So we can see what looks to be a pretty good thunderstorm in this example across the state of Kansas. Interesting features, some higher, colder cloud tops across the Rocky Mountains, and then other areas that, well, not a whole lot going on, say across the Dakotas and down here Tennessee into North Carolina. Again, how does infrared satellite imagery work? Different layers are going to emit different amounts of infrared energy. And so here we have a lot of infrared energy being emitted by a relatively warm low cloud, a less amount of infrared imagery being emitted by a relatively cold high cloud. These reach the satellite, and then we can basically take that data and apply, again, computer algorithms to have it do output in which is understandable to let us know about what level the clouds might be at, or at times where it's simply just hot ground. Finally, we look at water vapor satellite imagery. Here we look at what amount of water vapor may be running through the mid and upper levels of the atmosphere. Admittedly, we do very little with jet stream imagery here in MET 103. It's one of those things that is interesting to look at, but is more reserved for a number of classes moving forward in the meteorological curriculum because it's not really looking at weather down by Earth's surface. We're more looking at features that help us to identify where there may be a jet stream, troughs, ridges, things that, in fairness, have really impacted our weather and your lifestyle over the past couple of weeks with the deep trough cold temperatures and snow. Here, if nothing else in this image, you should be able to pick out this big swirl in the atmosphere, this mid-latitude cyclone that would have been going strongly across the Dakotas, a lot of mid-level moisture extending out ahead of it and along the boundaries, and so there's a lot that as meteorologists can pick out on this type of an image. And so that's going to end our video for this week. I'm going to keep it simple and make it one video. So hopefully you made it to this point. We will re-engage on general circulation starting on Monday. Take care, have a good weekend, and happy studying.